I'd like to show you some of the different mutation types that can occur. I don't need you to memorize all of the names of these different mutation types. I just want you to be familiar with some of the things that can happen when a mutation occurs. So all mutations are categorized into two major categories. You've got point mutations and frameshift mutations. So I want to show you what each of those would look like, starting with point mutations. Point mutations are the change of one single letter in the DNA. So here, my DNA strand is ACA. That would transcribe to an mRNA of UGU, and the resulting protein would be a cysteine amino acid bonded to another cysteine amino acid. And I would use the genetic code to figure out what amino acids these are. Now, if one single letter changes, that can cause a lot of different issues. So we're going to go through those issues, but the first one I want to show you is, let's just change this A to a C. So I'm going to erase that A, and now my DNA sequence is ACA-ACC. So if I transcribe that into an mRNA, now the mRNA is going to read UGG, and the resulting protein is no longer a cysteine, this is a tryptophan. Okay, so by changing one letter in the DNA, we end up with a completely different amino acid, and that may cause the protein to fold funny, or a plethora of other things that could happen. So the next type of mutation is called a frameshift mutation. Now, we talked before in an earlier activity about how ribosomes read 3 letters at a time on the mRNA, and those 3 letters are called codons. So if I add or take away a letter in the DNA, then I can really mess up the order of codons. That can have some pretty intense ripple effects. So let's look at what that might look like here with our frameshift mutation. So again, our first row is the DNA. So we've got ACA. If I transcribe that to mRNA, that's UGU, and then I just have 3 cysteines bonded together as the resulting protein. Now if I add a letter, so this is going to be an insertion mutation. Let's just throw another A in there. Now all of a sudden, my entire codons have shifted down a letter. So my mRNA is now UGU, UUG. So what are UUG protein? What is the amino acid they code for? Now my protein is no longer cysteine to cysteine to cysteine. My protein becomes a cysteine bonded to whatever UG codes for. It happens to be leucine bonded to another leucine, and we just have an extra little U sitting out here that doesn't code for anything. So this frameshift mutation can have really vast effects on the rest of the protein, because you're changing the sequence. You're changing the sequence of codons that come after it. Now I can break our point mutations down into 2 more categories. So point mutations can either be a missense mutation or a nonsense mutation. The example we did up here with the cysteine turning into a tryptophan is a missense mutation. We had one amino acid change, and probably the rest of the strand is going to turn out just fine. So we call these missense mutations. Now I want to show you what a nonsense mutation would be. In a nonsense mutation, I'm only going to change one letter again. Remember, a point mutation is just one letter change. So I'm going to change this A to a T, which would then code for an A in mRNA. And now, instead of this being a cysteine, it's actually a stop codon. UGA is a stop codon. So my ribosome is signaled to stop translating, and that can end the protein way too early and result in a protein that's not even functional, that can't even do its job because it's not complete. Okay, there's one last type of point mutation that we can get. So remember, point mutation means we're changing one letter that may result in a change or not. So a silent mutation is actually when there's no change to the final protein. So if I have this ACA again in the DNA, resulting in a UGU mRNA, then my proteins will be cysteine bonded to a cysteine. But let's say I change this A, say the mutation changes the A to a G. So I get an ACG. That means my mRNA will be a UGC. And here is the freaking cool thing about the genetic code. If you remember back at that chart, there are several codons that code for the same amino acid. So in this case, changing this to a C and getting a UGC codon, I actually end up with a cysteine protein, or a cysteine amino acid still, and my protein doesn't change. So I can end up with an identical protein even though there was a mutation. So not every mutation is going to result in a change. However, there's lots of different things that can happen, as you can see, and depending on what happens, and depending on if our bodies can fix it, realize that there was a mistake and fix it soon enough, it may not affect us at all. We just don't know when those changes will happen and how they will affect us.